We're switching to GLJ, signals dropped. Finished.
We just saw the signal drop in case we change the test.
We're seeing heartbeat drop again after the switch. Things are looking good. Guys want back again. Vehicle reports entry interface. At this time, we'll begin pressurizing the propulsion system to increase the thrust of the system. We use that for all maneuvering in the atmosphere. We're about to.
Odyssey is a spacecraft that's in orbit, and they're using that to amplify the signal to relay the
We're
signal.
standing by for guidance start guided entry.
We're using the Odyssey spacecraft as well to communicate to the Earth because the Earth has set the Mars
The engine that will be getting the number.
I can see they've got some flags there too.
Feel the atmosphere as we go in here. The vehicle just reported via tone that it has started guided entry.
So what's happening is that the spacecraft is sending data back from each checkpoint, so you can be slightly optimistic at each checkpoint.
At this time, the vehicle is beginning to steer its way to the target. Starting first and anchor first. First and anchor first. We have seen peak deceleration. We passed peak heating and peak deceleration. Just reporting that we are seeing G's on the order of 11 to 12 Earth G's.
Flight GDSA.
GDSA flight go.
We are processing data from Odyssey.
Yeah, that's good.
Please.
Everything's normal.
Copy, day reversal 2 complete.
Okay.
Standby flight. We have a connection, but we actually do not have any data yet.
Copy. We can expect some intermittent contact at this time as the signal gets increases to expect more. And copy 10.
Please listen to this update. We've entered heading alignment.
Very good.
It's still the easy part.
Heading correctly to target.
Yeah, we've been terrified for
Minus 1.2 kilometers.
1.2.
DLT is reporting that we are, that things look pretty good at the end of range control. We have control the converge on the error. We should be heading toward the target. Flight EDL, the TDS warning is okay.
That ellipse represents the uncertainty of exactly where we're pointed within the crater. So they're talking about the downrange or uprange error in the which all looks good.
During the setting launch phase, we're flying almost horizontally like a plane. We're going about Mach 2.4 at an altitude of 17 kilometers or so.
Next thing you'll hear is parachute close.
New technicians are excited to go.
Indicating that everything is fine. We're in heading alignment. We are standing by for straight up flight rate at parachute deploy. Vehicle continues to decelerate down to about Mach 2. As a reminder, we should have parachute deploy around Mach 1.7. We're at 15 kilometers altitude.
We've begun engine balance mass jettison. Predicted minimum downrange is 1.597 kilometers.
EDL Labs, Odyssey Systems on EDL Labs.
Parachute deploy.
Next thing we'll jettison the heat shield?
We are decelerating. Risk mode, we are decelerating, descending 150 meters per second.
Dynamic phase, come back again with risk mode dynamics.
Risk mode is nominal.
We're at 8
Down range.
That filter converts to the velocity curve to the point. We define the ground with 2 AR. Now to the equilibrium. Feature separated or on the ground command zones due to relocation as expected. We're using by to find the Emily engine to preparation for power play. We're down to 90 meters per second at an altitude of 6.5 kilometers descending.
Is everybody getting this? Can everyone hear this?
Flight video, we got some video warnings.
This guy walking around is
I didn't get that
having
when low station power director of communications at this time. We may have lost it already.
we call him Elvis actually.
We're down to 86 meters per second at an altitude of 4 kilometers descending. We've lost zones from Earth at this time. This is expected. We're continuing on Odyssey's launching.
That's the Earth setting below the Mars area.
Ground solution equals minus 10.8 meters, vertical velocity of minus 80
We are finding 8 meters of light start enabled getting by professional separation.
I think these animations are a bit ahead,
Signal Odyssey is still strong.
in case you haven't figured it out.
We are in power play. We're at altitude of 1 kilometer descending. About 70 meters per second.
Signal Odyssey in the air.
Down to 50 meters per second. 500 meters in altitude. Standing by for Skytrain.
Constant velocity accordion nominal. Altitude error 5.9 meters.
We found a nice flat place. We're coming in ready for Skytrain. Down to 10 meters per second. 40 meters altitude. Skytrain started. Descending at about 0.75 meters per second as expected. Expected final petrol leak.
Signal Odyssey remains strong.
Tango Delta nominal.
Yeah, you'll come configure stable. You're in stable. UHF is good. Touchdown confirmed. We're seeing
Yes! Done.
They're elated, and you can imagine describe how they're feeling right now. Just a decade in the making. I can't. There's no words.
There's almost nothing else nowadays on Earth, to be honest with you. Dedicate so much of your life to something.
curiosity.
Just to say
Sequence is kicked off, waiting for images.
Signal Odyssey remains strong.
Images are starting to come down. We're beginning to get
Pink thumbnails coming down.
Odyssey data is still strong.
Odyssey data is very strong.
So does that mean that they're going to get an image back?
Well, from what I understand, there was very small chunks of myself. So, There's a very small chance that there may be images down from the descent imager basically straight away, and it sounds like that might be happening.
I think the first image might be quite a small thumbnail from the rear house.
There we have it.
That's it. That's the
That's
surface
the
of Mars.
surface.
Yeah. So Pete, that's to understand what the wheel is sitting on, right? It's not very clear.
Yeah. So you can see this is a fisheye lens. It's quite a thumbnail image, but what you can see, which is good, is that even for a fisheye lens, the horizon is pretty straight in the middle, which means it's lying on the background, it's not on the side.
They've got a wheel. Hopefully
It's
it's
looking
going
at
to
the back of the rover at about wheel height. It's one of the hazards of all those cameras.
On the run.
Yes.
Yeah, you can see the horizon in the background, and it's bent because it's a fisheye lens. And I think from what I can hear, they're saying there's a wheel in the shot as well. That's a really, really unexpected but amazing good thing to see.
Well, it seems to have all gone to plan, my goodness, but they're not able to crack open the champagne yet, still lots of work. They're going to be doing it this morning, isn't it?
There's more stuff. Any minute now. And up. 256.
Okay, okay. We're going to start. Go ahead. So, we have landed out at the time we thought we would, and we now have our first image.
We have our first image. This we've got is a 64 by 64 thumbnail. The front, a rear has-cam image. You can see the shadow there. I'm not sure exactly what our orientation is of the vehicle, but we're looking through it. I think in just a few minutes we might get even a larger 250 to 256 frame pixel image of that same end. So we're looking at the horizon is actually the distance. You can't really tell that. We're looking actually at the shadow of this late afternoon sun.
So these are the rear house cams.
That's the rear half cams.
And it
so
does have a dust cover on it.
it does have a dust cover, but it's the dust that covers the problem. It's the fact there's dust in the air because we've just blown dust all over the place, whether it's in inches.
That's actually why they had to use the crane, because you can't use the engine all the way down to the surface.
That's a better image.
That's a much better image. That's
So
amazing.
there could be more.
There could be more. If we wait, we might get, oh yeah! This is the 256 image. You see dust particles on the window. You can see the horizon there in the background. And there is the wheel of the rover safely on the surface of Mars. I can't believe this. We might get another one of these, and if we're lucky, and before Odyssey goes away, we'll get 2 more of these images going the other side of the vehicle, and also probably dusty. This is amazing.
So let me explain. That's actually precisely what we would have thought the surface would look like in this place. The problem is that, you saw this ellipse, which is the landing site region. There's a lot of uncertainty about exactly where you'll land in the ellipse, which is, within 10 or 15 kilometers. We characterized the hazards in that landing site, but there are always some boulders, some larger rocks, and things like that. So even if you really try to minimize the risk, there's some chance you could land just by chance on this boulder or on this rock or in a tilted fashion or on something like this. So it's really reassuring to see that it is what we thought it would be.
Galaxy transition is about to end. It's about to set below the peak of Mount Sharp very shortly. So this is about all the data we're going to get, but things look great.
And the reason we had to use the crane was because there is dust there, we know that. There's a dust in most of Mars, it's dusty actually. And so if you use those rockets to power all the way down to the surface, it would generate, it would bring so much of that dust up into the atmosphere, it would coat the whole rover and all the instruments and all that stuff. So you had to keep those rockets away from the actual rover.
That's the shadow of the rover. Wow, that's a great picture. That's the only dive on the dust cover.
It's about 25 plus 3 on Mars at Gale Crater, so you've got a shadow. Yeah, pretty shadow.
Does anyone have any questions at all while we're watching this? About anything that we see?